Unity has a built-in point effector component, but only in 2D. Therefore, we need to create a custom script to achieve the same result in 3D. To demonstrate what an effector does in 2D space, I created this little scene right here. The red circle is repelling, while the blue one is attracting physics-based objects. Both have a point effector component attached to themselves. They only differ in the force value. To repel stuff, the value has to be positive. For attracting, negative. And the white ball is our physics-based object for reference. A rigid body component is attached to it. When I start a scene, the ball falls down, gets repelled, and then attracted. It's pretty easy to play around with this. For example, we could just add another attracting ball right there, and when we now hit play, we have created a little gravity game. I love it! Now let's switch over to 3D. After we have now created a scene in 3D, let's add some environment as reference into the scene. A game in which a 3D effector could be used in is, for example, a sci-fi game, to mimic the behavior of a black hole. So, let's add a sphere and give it a black material. Awesome! Now go all the way down the sphere and click on the bottom Add Component and write Effector 3D or whatever you like to create a new script. Put this script from your overall assets folder into your scripts folder to keep everything organized. Then double click on it and open it up in your code editing software of choice. First, delete the start function. We want that the effector works all the time and not only in the beginning. So we have to write our code in the update function. After you did so, create a new public float radius. This value will decide how big the area is in which we apply force to physics-based objects. And for setting this force, we need a second public float force. Switch now to the update function, create a new vector 3 called Effector-Pos and set its value to the transform.position of the object the script is attached to. This is only to keep things organized. You could also just use transform.position all the time instead of Effector-Pos, but the code gets way easier that way. Now we have to create an array of colliders by writing square brackets behind collider. We'll call this array colliders and set it equal to physics.overlap sphere with its center at Effector-Pos and a radius equal to our radius float. That way all colliders that are in this sphere get stored in our collider array. To affect every single one of these colliders each, we have to write for each open brackets collider to set the type of components we are interacting with. Hit, you can name this whatever you want, it's just another variable. And finally, in colliders. Close the brackets now and open two braces and hit enter. Now we will say what we actually want to do with the collider hit. If we want to apply any forces to an object, we need to have a rigid body. So we create the variable RB for rigid body and set it equal to hit.component rigid body. If the game object to which the collider hit is attached to has a rigid body, RB will be equal to it. But now we still have to check if this game object has a rigid body, so we'll write a small if statement and look if RB is not set to null. If it would be set to null, that means that there isn't any rigid body attached to the game object and we do nothing. But if not, we want to apply a force to this rigid body. For this, we will use the add explosion force order already built into Unity. Normally you would only call this once to add a rapid explosion force to our object in range, but we want to create an effector, so we call it all the time in the update function. We set our force float in place for our explosion force. Don't forget to use time to delta time so that the force is applied on all devices at the same time, and set our Effector-Pos as the center position of the explosion. Logically, for the radius we'll use our radius float. When you save the script, you now can go back into Unity and play around with the two variables. If we now hit play, you will see that force gets applied to any physics-based object. When the value of force is positive, the objects will get repelled. Let's turn it off a bit and you will see that the magnitude of repulsion has changed dramatically. If you now change the value and turn it negative, you can see that the objects get attracted by our script. You can even play around with it a little. Now you have a custom 3D point effector script. If this video was useful to you, please give me the honor to subscribe and liking the video. And if there are any other topics I shall cover, please write a comment. See you again!